What I put together, and this is not meant to be definitive, it's just to kind of think about what we've heard over the last couple of days, and this is my interpretation, and I don't want to force it on anyone, but this is kind of my interpretation of the themes that I heard. And I think that thinking about the themes will be useful if we decide to go somewhere a little bit further with this particular group or this workshop. It's been one suggestion that's been put out is perhaps we can write up a report from the workshop to first of all summarize what we've heard, and then we've written down a bunch of topics to start working on what are the right research topics in this space. And I think one of the challenges we heard is that the space is really hard to define. And so that was what the first point is that we've got a real convergence. Not news to anyone, I don't think, although I don't think it's been widely acknowledged in the research community, and we're not seeing it in practice in the sense that a lot of the technologies we've talked about in the last couple of days are really coming from the programming languages community and not necessarily from the operating systems community. And we're trying to solve many of the same problems. And some questions about where do we draw the lines, and how many levels of virtualization. We saw that in a couple of talks as well. I guess the point I want to make here is that in the absence of coming up with some sort of reasonable technical basis for this decision, the decision will be economic. Right? So, operating systems will come to be for economic reasons, and the layers will be drawn because that's where the value proposition is for a given company or a given open source project and so on. I think actually we got to do better than that, because what we're going to end up doing is layering one on top of the other. I need my function, I'm going to emulate it on top of your function, and so on. So I think there's a challenge there to think about whether there's a real technical basis for making some of these decisions. Next point is about hardware-software co-design. I think we heard that from a couple of different sources. This is a touchy subject, and one that I'm always very, very careful about, because designing into hardware is not a trivial activity. It's not a cheap activity. Hardware instructions live for a long time. They have to be useful to a lot of people. That's my view. That doesn't say it isn't a good idea. What it means is we have to be tremendously careful when we go about designing hardware extensions, particularly for what might be an ephemeral software system, right? So I'm not saying that's true of any of the things we heard today. That's just my kind of blanket. Let's not be too hasty about any of this stuff, but let's take seriously the fact that both Azul and Intel came up here and told us that it's time to do serious co-design of virtual machines and hardware. So that's another thing. Next one is we see that language and VM diversity is good. I don't think anybody will argue with that. It's not good if the seams show through to the developer. So if the developer ends up having n languages on his desk, and he's got to have n bridges between, or n squared bridges between these languages, hopefully it's not n squared, but anyway, then that's a nasty problem. Particularly if he's doing the static proxy generation, if he's doing the coding and the mucky interfaces between the languages, and particularly if it doesn't work and it doesn't perform. So those are what I mean by seams. Okay? So the challenge here is, of course, we want to nurture innovation in programming language design and virtual machine design and implementation, but we have to keep in mind that we're doing this for developers and customers and users to ultimately get their job done, right? And so that's something I think that we've lost sight of a little bit here. I think that CLR and the scripting communities have thought of this about a little bit more, but the reality is, customers have a whole menagerie of these things at their disposal and are using them. And we've got to make sure that we can make them work together. And of course, there's degrees of working together. So we saw that from Brendan's talk, where there's bridging, there's awful stuff you can do to connect, and I think we go about this incrementally, but we have to keep that in mind all the time, especially as we invent more and more of these things. Next point we heard about is an excellent one, is that software quality increasingly depends on a widespread use of type-safe languages and runtimes, and in particular virtualization and metadata as a realization of that. So, I mean, Andrew's talk was quite good. It seemed to say, fairly strong safety guarantees are just around the corner if we can only build our systems more carefully. you know, I guess you hear that story a lot, but the fact is, you know, we're in a quality crisis in software today, not just, you know, some of it is exhibited in security problems, but by and large they're exhibited in just bugs and crashing systems and malfunctioning systems.
But they said that in '68. I mean, this is not new.
What's not new?
The quality crisis.
So we've been in a crisis for 36 years?
Yeah.
Oh, well, we're used to it by now then.
Just more software too.
That's true. I would argue there's a lot more critical systems operating today on much shakier software than there was in 1968. But you're correct. It's not a new problem. I think it's just becoming more pressing for the everyday person, not just for large businesses running on large systems.
I could suggest another bullet. Software performance depends on widespread elimination of virtualization.
Yes, that's the tension, isn't it? Yeah. And so, but we can't start there. I think that's been historically the problem is we've started with we have to make the stuff run well. You know, the challenge now is we have to make the stuff run right. And then the performance guys have a hard challenge, clearly. There's no question. The other theme, and one that's very refreshing, and the reason, you know, why we brought a diverse audience here is that the promise and reality of these virtual environments are very far apart. You know, practitioners, I mean, Christoph made it very clear that they see the light at the end of the tunnel, they know the promise, they get it, but they don't have it. Okay, and that's not necessarily a comment on what we know, what the research state is. It's about being able to execute these systems and get them working. You know, again, it goes back to quality software, of course, but it's also about developing the right kind of usability, the right tools around the environment to make these things actually usable and predictable. Interoperability of virtual and native code is a subtle and important problem. So this is not new either, except that it has kind of uniformly been ignored, I think, in a lot of virtual environments that we've built. So I think, you know, one thing that I take away is that, you know, we really do have to get serious, and I'm glad, Doug, that we're doing some work to standardize this, but I don't want to see a hack and slash on Java for this either. That we have to be careful about how to do this, and we don't want to do it in a way that invites people to do this regularly by any means, right? But we have to enable these virtual environments to embed safely and efficiently in native software. You have to be able to extend them when it makes sense. You know, not for every guy to go and use C++ because he wants to use C++, but because we absolutely need to for a variety of very good reasons. And then the other point, you know, is, and we'll see lots more of these new opportunities for virtual machines, and this goes back really to the software quality point. You know, new opportunities because new communities of programmers want to use this type of programming and these types of systems are coming from, you know, surprising places. Database engines, from high-performance computing and real-time systems are 3 examples that we saw. Now, surprising to me, maybe not surprising to people in those communities, but surprising because these are communities that you know, have tried and true methods that go back a long time, you know, and actually taking these systems, which, you know, to be frank, kind of barely work today in the environments in which they've been put commercially, and saying, you know, go put it on your jet engine, you know, make your terabyte database run it, or try to run a massively parallel physics simulation on it. You know, that's a completely different thing. I think it's absolutely what we need to do. But, you know, again, more challenges for the community, both on the usability and performance and robustness. Yeah, go ahead.
I think you said this elsewhere on your slides, but it's worth adding to this list, operating systems.